We implemented a system to demonstrate the different components of the PID controller. The target moves in a two-dimensional direction, while the laser attempts to accurately track the target in real time. To achieve this feature, we implement a MEMS mirror to redirect the beam from the source to the target wherever a change is introduced. The MEMS mirror is used in the feedback loop to direct the beam onto the target. However, this functionality does not always result in perfect tracing. Here we are dealing with an untuned system. In other words, there is no P, nor I, nor D implementations involved. Our main objective is to trace the center of the pink circle with the laser. However, we can see that it's not doing the best job of tracking it. This is due to the steady-state error of the feedback system. The purpose of this demo is to demonstrate the different configurations of a PID controller, and how the laser may accurately and precisely track the center of the pink circle. As we can see, increasing the proportional gain Kp significantly decreases the steady-state error. This does indeed solve our problem. However, we introduce a new problem, which is a severe increase in oscillations. We then decide to attempt to configure a PD system, which is implemented by adding a derivative term to the proportional gain. As we can see, there is almost zero to none oscillation, which is what we try to acquire in the P system. However, the downfall of the PD system is that there's a lot more steady-state error in comparison to the P system. Instead of the PD control, we attempt the PI configuration. This leads to a potential oscillatory response along with a slow response time. As we can see with the laser's slow response, it's quite vivid that it's taking a longer time to reach steady state. We will need further adjustments. With proper tuning, we are able to obtain a PID controller. The PID controller consists of the three previous implementations, P, PI, and PD. The new system combines the advantages of each of the implementations and removes the fault of each of them. With this new configuration, we are able to eliminate the steady error and the overshoot in addition to shortening the response time. As we can clearly see, we are now able to achieve that pinpoint tracing of the pink circle, regardless of how the target moves.